Hello again everyone, welcome back to ptet.chemistry channel. So in this first example of studying of practical methods of studying rate of reactions, so we have calcium carbonate reacting with dilute hydrochloric acid. So calcium carbonate is your marble chip, hydrochloric acid is in aqueous state, and it's going to produce you calcium chloride. This is your metal salt. Metal carbonate plus acid give you metal salt, carbon dioxide gas, as well as H2O liquid. Here you're going to investigate the rate of reaction at 3 different temperatures. So this is what is changing. What you change here is not anything else but temperature. So what you change is going to be your x-axis. Your x-axis is going to be your independent variable. So they are on the x-axis, they are on a horizontal scale. They are what you call the independent variable. Whereas what are you investigating? You're investigating the rate of these reactions, so you need to record time. So we need to record time for these reactions, time to collect a specific volume of gas, for example. So you record the time using a stopwatch. Stopwatch is an apparatus that you have in the lab, and you use that to record time. And what you're going to get is this is on the y-axis, and the y-axis is going to be your dependent variable. Remember I talked about in the last lecture tutorial where I keep on saying, why are you so dependent? Why are you so dependent? So y-axis is the dependent variable. Here we have a rubber bunk. So this is like a rubber bunk. It's basically to seal the system. Seal the system meaning to make sure that any gas produced cannot escape through the side. It can only escape through here, and therefore you'll be collecting the gas inside this apparatus, which is called a gas syringe. A gas syringe is this apparatus. So B is going to be a gas syringe. Name the apparatus A and B. B is your gas syringe. You use it for gas collection. It has got graduations. Graduation meaning these lines that allow you to measure and record the reading on the volume of gas produced there. What is apparatus A? This is a very specialized apparatus that you can find in any chemical laboratory. Therefore, what you have A there is what you call a conical flask. The design is such a way that it's not flat entirely going up, because this reaction is going to produce a lot of bubbles as a result of the gas being produced. You're going to see a lot of bubbles. So the bubbles will go up the side, but then it will flow back down as a result of the design of a conical flask there. What else do they want? What is meant by an excess of calcium carbonate? Excess means more than enough. More than enough. So if you have more than enough solid to react, that means the other reactant you don't have enough of it, because here you have excess of calcium carbonate. You have excess of this, means you don't have enough of the HCl. So if you have excess of the solid, not all the solid will react. So excess means not all will react, not all of the calcium carbonate. Why did I talk about calcium carbonate? Because the question asked me on calcium carbonate. So not all the calcium carbonate reacted. And the calcium carbonate is a solid. If it is a solid, not all of it reacts. What do you see at the end of the reaction? You will still see some solid. Some solid remain. Some solid calcium carbonate will remain at the end of reaction, because it's in excess, it is not used up, therefore you still have a little bit of it left over at the end of reaction there. Now the student does experiment 1 at 20 degrees Celsius. Name a piece of apparatus that can be used to keep the temperature constant. So remember, we wanted to change the temperature at 3 different temperatures. So this is what we want to change. But when we want to record the rate of reaction at a particular temperature, at one particular temperature, we want to make sure that the temperature stay constant for the time being when we are trying to record the time taken for the rate of reaction, right? So what you can use is you can use a thermostatic water bath. So this is a physics term. Thermostat is an apparatus. It's actually a specialized piece of electrical equipment. You can change you can change the setting in such a way that you can control the temperature, and it will keep the temperature constant. Thermostatic water bath. So water bath means you are not heating directly with a Bunsen burner. Instead, you are putting this in a container like this. Nope, don't want that. like that, and then you can have a thermostatic water bath. Thermostatic means it's controlled by a thermostat. Thermostat, you can look at what it means, but it's basically something used in physics in order to control I think it's a flow of voltage or something, and in such a way you can control the temperature. Okay, thermostatic water bath there. Now the student does 2 more experiments. Similarly, by changing the setting of the thermostatic water bath, you can change it to these 2 different temperature, and you can keep it constant at this particular temperature while you are reading the time taken for the rate of reaction. But what do they want? They want 2 variables that the student need to keep constant. So that temperature is the only variable because you do not want to study anything else. You only want the temperature to change. We only want temperature to change. We only want 3 different temperature. So this is what you change. What you change is on the x-axis. So what you change is going to be the independent variable because that is what you change. That is on the x-axis. What you record is the time taken for the rate of reaction, for the volume of gas to be produced. So, that is your y-axis. But this one is to be kept constant. This thing is what we have discussed before. It is what you call control variable. Control variable that can affect your rate of reaction, but you want to keep them constant throughout the experiment so that they are not affecting what you're trying to investigate. We know a couple of factors that could affect rate of reaction, one of which is your concentration of the acid, because we talked about earlier, back in the early learning objective, that changing concentrations could affect the rate of reaction. We are trying to investigate temperature, so we don't want concentration of solution to change. We don't want the surface area of solid to change as well. So if you have used a powdered form of marble chip, you have to use powder form for the other reaction as well. But I guess variables wise, the easiest one would be, first of all, to talk about the concentration of the acid. Which acid did you use? You use hydrochloric acid. If you read the question, hydrochloric acid there. So it's the concentration of the HCl aqueous. The solid do not have concentration, only the aqueous solution does, all right? The type of, I guess, not only the type, the mass of the calcium. The mass wouldn't matter because the calcium carbonate is in excess anyway. So it doesn't matter if you use the same mass or not. Not all of them will react. So in this case, the mass of calcium carbonate wouldn't matter. But you want to have a surface area of the calcium carbonate solid. So meaning to say, if we use powdered form, then use powdered form for both. Use the same powdered form for both experiment, for the other 2 experiment as well, so that surface area cannot affect your rate of reaction there. Okay. Now the student plot a graph of the results. Remember that we are changing temperature here, so we change temperature. If you read the reading, experiment 2 was done at 40 degrees Celsius, experiment 3 was done at 60 degrees Celsius. So you have experiment 1, experiment 2, experiment 3. So this was 40 degrees Celsius, this was 60 degrees Celsius. If you read the question, experiment 2, 40 degrees Celsius, 3 at 60 degrees Celsius. Experiment 1 was at 20 degrees Celsius. This is not an enzyme reaction. This is simply increasing temperature from experiment 1, 2, and 3. We get the same amount of volume of carbon dioxide because in terms of reacting masses, in terms of reacting volume, we have not changed anything. We are using the same concentration of HCl, which is completely used up. So we are still going to get the exact same volume of carbon dioxide. What is changing, however, is temperature. Temperature affects the kinetic energy of your particle. As you increase temperature, particles have more kinetic energy. Particles have more kinetic energy. They can move faster. They can collide more frequently. And when they collide more frequently, they can lead to a faster rate of reaction. So the higher the temperature means the faster the rate of reaction. How do I know which reaction is faster? This is where gradient comes in. If I draw a line like this is like a tangent to the curve here, this green one versus a blue one, for instance. So this blue one is for the second one, and then I'll draw a black. No, black is not a good color. A pink one for the third one, let's say. So if you look at the line there, what can you say about the line is that the line get less steeper. So less steep, meaning to say gradient decreases. Gradient of the line. Gradient is going to be the change in the y divided by change in x. This one is your lower secondary mathematics, where you learn y2 minus y1 over x2 minus x1. This is your change in y over change in x. That is your gradient, how steep the line is. The less steeper the line, that is going to be your rate of reaction. So the rate decreases as gradient decreases. So that means this is the slowest rate. So the pink one will be the slowest rate. This is the slowest. And then the green one, this is the steepest gradient. So the green one is going to be the fastest. The fastest reaction is going to be the one at the highest temperature. So that is going to be 60 degrees Celsius for experiment 3. Whereas the slowest one is the one with the lowest or the smallest gradient, not very steep at all. The one at the lowest temperature, that's experiment 1, which means the other one is experiment 2 there. Okay. How the graph, describe how the graph are used. Well, we can see from the tangent, we can see from the gradient of a tangent, gradient of tangents drawn at time equal to 0. The three graph have different gradient. They want to talk about the fastest rate. So fastest rate will be the steepest gradient. So fastest rate has the steepest gradient. Gradient is the key word here. Steepest is the superlative English, S-T-E-E-P-E-S-T, steepest gradient. The gradient has the highest value. We're already done writing a number there, so that one is done. State how the graph shows the reaction stops. I already talked about this earlier in the earlier graph. Why does everything stop here? Because there's no more volume of carbon dioxide being produced. So that's how you know the reaction has stopped, has finished, because it gets horizontal at the end there. So the graph levels off to a horizontal line. So meaning to say no more carbon dioxide gets produced, no more CO2 is produced or was produced. That is when there's no more change in the volume of gas. That's why the level off horizontally there. Why do the reactions stop? Why do the reactions stop? Well, why is there no more carbon dioxide being produced? You look back at the equation. How does one get the carbon dioxide? You get the carbon dioxide from the reaction of calcium carbonate, the marble chip, and the HCl. If they are used up, no more of this or no more of that, that means no more reaction can take place, and therefore no carbon dioxide will be produced. So the reaction stops when there are no more reactants. No more reactants are present. No more reactants are present to react. When you have no more reactant, you get no reaction. When you get no reactions, you get no gas being produced furthermore. Okay, I think I'll leave it here for this lecture tutorial. So we have spent this lecture tutorial, quite a short one, to talk about gradient. Gradient is how steep the lines are, especially when you are thinking about volume of gas being produced against time. It could also be the change in mass or the loss in mass against time, such as the one that we covered in the last lecture tutorials when we talk about the other method of monitoring the rate of reaction, which is to do with the loss in mass. As you are losing out the gas here, you can plot a loss in mass against time. Similarly, the gradient is going to tell you how fast the reaction is going, the rate of reaction. Of course, the one covered in this question was to do with the volume of gas collected against time. Similarly, the gradient is going to tell you how much gas is being produced over the time there. So it's going to tell us the rate of reaction. As you can see from the gradient, they are different. The steeper the gradient, the faster the rate of reaction. This is to do with investigating different temperature. So the fastest reaction, it happens at the highest temperature, since the particles have a lot more kinetic energy as temperature increases. This was the year 9 kinetic particle theory, stats of matter idea there. Okay, I'll see you in the next lecture tutorial. Thank you for watching. Don't forget to click the button on the bottom right to subscribe to my channel and follow me at ptet.chemistry on Facebook, Instagram, Twitter, and Telegram to get connected.